right, Mr. Peel and Mr. Burt, I'm right on it. Oh, thank you. Bye. Oh, hey guys. I'll be right with the lesson. Let me just go get ready for it. Hello. So this is a just quick review of simplifying with square roots and Pythagorean theorem. So our first step is simplifying square roots. Now, some of you might remember how to do this, and some might need a little bit of a refresher. But when I'm faced with problems like this, what I'm doing is I am breaking down the number and trying to find perfect squares. So for 98, what you would look at is what two numbers multiply to 98. In this case, 2 times 49 works. Now, what you'll notice is I can take the square root of 49. The square root of 49 is 7. So the 7 goes on the outside of the parentheses because I can take the square root of that one. The 2, I can't find the square root. It's a big decimal. So I'm going to leave that inside the square root, and that is my answer. Now, there's two different ways of doing 128. So my first way, okay, is let's say I have 128. I start breaking this down. What two numbers multiply to 128? Well, 2 and 64, 4 and 32, 8 and 16. There's a bunch of, these are pretty much all the numbers that I would think that you guys would come up with. Now, if you think of these as in square roots, well, if I take this first option, 2 and 64, so if I break this down into 2 times 64, I notice I can find the square root of 64 really quickly, and that's 8 times the square root of 2. But let's say you look at these other two numbers, and you say, well, 4 is a perfect square, so let's take that example here and break that down. So I have 4 times 32. Well, square root of 4 is 2. But I can now break down the 32 into 16 times 2. So now I have this situation where it's 2 times the square root of 16 times 2. Well, square root of 16 is 4. When I do that, it comes out as a multiplication with the 2 that I already took out. This 2 is going to stay inside the square root. 2 times 4, 8 square roots of 2. There's two different ways that you can get your answer, but in the end, you're just trying to break it down where I cannot break this number down anymore and get some nice perfect squares. The second part of this lesson is about Pythagorean theorem. Pythagorean theorem, you'll notice, or remember, is a squared plus b squared equals c squared. C is always the hypotenuse, remember? The hypotenuse is always across from that right angle. So in this case, it's 10 squared plus 24 squared equals c squared. 100 plus 576 equals c squared. I add these together. I take the square root, and that is 26. So that is my value for C. Now, the harder problems come when you have something like this. So I put it's a different type of setup because now I have my C. So I'm going to say x squared plus, you don't even know what that is, but I'm just going to write that. So now what I do is I square the 14, which is 196. But how would I do this? Well, the trick with this is, if this is a square root and this is a square, they're opposites of each other. They're inverses, like multiplication and division. They undo each other. So what happens is I'm left with that. It just cancels the square root out. Now when I subtract the 46 from both sides, I have 150, and then I take the square root of 150. Now, I could get a decimal for this. It's going to be 12 point something, but that's not what I want. What I want is you to break this down. Now, whenever you're dealing with 150s, 175, 125, you got to think, oh, it's 5 times something. So this, okay, or 25 times something, like quarters, okay? So this is really 6 times 25, or 25 quarters. So now I take the square root of 5, or square root of 25, I get 5 square roots of 6. And I know that I'm done here because 6 is really 3 times 2, and I can't find the square root of either one of those numbers. Please let me know if this helped, if you have any questions, and please work on those practice assignments that I posted. Thank you.